We're having our attendees now. People are logging in.
Yes, I think we're up to, yeah, 61, 62.
Okay, we can start. Hello, everyone. Have a good day for all of you. We have a lot of people joining us today from Europe, also from Asia and in the US. So that's why good term should be have a good day. So we will be having our webinar again for this month, a live webinar. We had some sound issues in the last November session. That's why we want to repeat it together with Connor. We decided to repeat this event. Now we'll be starting with the content. Today we will be discussing microbiological contamination control in clean rooms and clean air environments. As you all know, the ISO 14698 is the international regulations that we will discuss today, the current situation in Europe and also internationally, and the evaluation to EN 17141. Let me introduce myself first. My name is Hasim Solmaz, and I'm the General Manager of Lighthouse Worldwide Solutions and EMEA Operations. I have different responsibilities in different organizations and regulatory bodies, like being head of delegation in Turkish Standardization Institute, and I'm one of the subject matter experts in cleanroom testing and in working group 3 for cleanroom test methods. I'm an active member of Cleanroom Technology Society of Turkey and the honorary chair of International Contamination of Contamination Control Societies, ICCS, and recently being a faculty member of IEST Contamination Control Institute. My dear friend Connor Murray, he will be the presenter today, and he's a principal consultant of Three-Dimensional Cleanrooms Limited, based in Ireland, and his background is an engineer in Masters in Industrial Engineering, and he's also subject matter experts in contamination control, head of delegation of ISO TC209 and also SAN TC243, and he is a convener in SAN TC243 working group 5, which we will be talking about EN standard today. He was the convener of this organization and subject matter expert group. And he has also become an ISO TC209 working group 2 biocontamination control convener for this working group, which will be updating ISO standards and aligning it with other international standards. He is also a chair of Healthcare Services Committee in TC5 and chair of Irish Cleanroom Society and board member of Board of Governors on ASHRAE Ireland. A lot of responsibilities, Connor. And today we are going to cover a couple of contents. First, we will be starting with current status of microbiological contamination control standards. There are international standards, EN regulation as well. So we will be discussing about the difference between ISO 14698 and these new EN ISO standard, as well as EN 17141, which is published in 2020, recently published. We will be discussing about these SAN TC243 working group 5, what they did so far to publish this new standards. And there will be an executive summary, evolution, and comparison of this EN regulation. And there are different fields of application other than pharmaceutical applications. We will be discussing about it as well. And we will take a look at GMP Annex 1 as well as EN 17141 similarities. Also, EN 17141 and microbiological contamination control will be our summary for today. Anytime you can click on the questions section and send your questions in. We are going to ask all these questions to our expert today, and we will be spending like 5 to 10 minutes end of the webinar to answer these questions. If you will not be able to complete all these questions, don't worry, we have your emails and we will get back to you after this webinar. Okay, Connor, welcome today. Stage is yours now.
Thank you very much, Hasim. Good morning, everyone. There will be a lot of tongue twisters in our conversation this morning between ISO 14698 and EN 17141, ISO TC209 and CEN TC243. So maybe I'd like to start off and go through some of those wording and terminology so we get clear on that. But today I'd like to take you on a journey and share with you the journey we've gone on as European experts in looking at dealing with biocontamination control, or more what we're calling today microbiological contamination control, that deals with effectively with microbiological cleanliness in clean rooms and clean control environments. So let's look at the status to try and go through this minefield of numbers. So first of all, we've got ISO TC209, which is the ISO international community, and the one we're familiar with is ISO 14644 of clean room related standards. And that's where ISO 14698 fits in, and that comes from 2003. The European mirror group is TC243, and we use what we call the Vienna Agreement for parallel voting. So enough of the technicalities on that side of it. There are two parts to 14698 from 2003, and there's been no revision after 17 years. And a lot of work has gone on in quality risk management in the life sciences area. And we went through a systematic review in March of this year, and the decision was to withdraw. So clearly there's a mood for ISO to change, but in the meantime, the EN version has been replaced by EN 1741. Then there's a new number because otherwise there will be a clash with 14698. And I talk a bit about that, but that was approved last October and was formally published in English, French, and German in August of 2020. So the left-hand side here shows the majority votes to withdraw 14698, and as part of that, the CEN community had shared a document of a summary I put together to show where the changes we'd recommended to the ISO global version of 14698. So let me again try and change and go through some of this with you on it, right? We had a working group too in TC209 back in around 2009, but the resolution was written in such a way that it created a number of technical difficulties. So really that carried on till 2014 and then was disbanded. And we decided in Europe that we wanted to take it on under a different resolution and mainly around monitoring. And we put together a European group and then took it forward to the current publication. We're now looking to go back to ISO to take the value of the work we've done in Europe and share it with the international community.
Connor, before we start from this point, could you please explain the difference between ISO 14698 and EN ISO 14698? Because we all know that the EN version is completely obsolete and the other ISO version is still available in some countries. Can you please explain it more?
Yeah, so the original ISO 14698 was applied both internationally and in Europe under EN ISO 14698. But because we've come up with a new version during the revision purely in Europe, and it's now got a new number, EN 17141, we actually withdrew EN ISO 14698. And that's why we end up with this issue around having two standards, an ISO 14698, and now we have an actual EN 1741. So you can see here in the current slide that because we have an ISO 14698 and we've withdrawn the EN version and we have a new number 17141, we have a gap and there's confusion and a misalignment, and we need to resolve that. Okay, and that's really the purpose of part of this discussion, is to share that journey and explain where the differences are, and hopefully we've a way forward. So we discussed this challenge that you've identified at our last TC209 meeting in October. And there was a new resolution, and that was to reinstate Working Group 2. I have been appointed as the convener of the Working Group 2, and we will be basing a new work item proposal on the EN 17141. And there may be changes to that, but that will be the basis of the document. The agreement has been that we'll have our first working group meeting before the middle of next year. And we are currently launching a new work item proposal to go for ballot to approve that in the international community. And the title of that would be microbiological control in clean rooms and associated controlled environments, with a view to revising 14698, so we've one number internationally, and then at that point we will remove EN 17141 probably in 3 or 4 years' time. So we're back to having one standard and an ISO 14698 probably in 2022. So I hope that goes through some elements of that for you. Again, the wording is complicated, but we're still dealing with the same subject matter, and we're more and more calling it microbiological contamination control, and that is aligning with the EMEA and EU and PICS Annex 1 discussions going on at the moment in life sciences. So let's go through some of the background to microbiological contamination control, right? And the first and obvious thing about it is that it is so variable. It's hugely variable. And it is quite different to particle counting, which just counts a particle. And there's no requirement to say what the particle is, whether it's organic or inorganic. And we need to recognize that the microbiological continuum is massive, and it comes across viruses and fungi and bacteria and molds, spores. And in terms of clean rooms, we, the people, generate the most of this contamination. And we generate probably 70, if not 80%. And the key area of risk is around manual manipulations, the interventions. And these are still the biggest challenges in microbiological control, even though we have isolators and robotics to try and remove the numbers of people, but we'll never eliminate, because we're dealing with living organisms and they're not easy to observe, recover, or measure, and we call them the unseen enemy. So there are fundamental differences in the application of microbiological control in different industries. So life sciences, we're very much around product sterility for patient safety. In food, we're dealing with more safety and presentation of foods, and because they're ingested, we're trying to make sure that we don't cause illness. And in healthcare, we're very much around infection control, because the patient is already full of microbiological flora, and we're trying not to contaminate with other people or processes or the rooms themselves. So we already have significant guidance in aseptic manufacturing in the life science industry. And we also have the difference that in some cases, like an operation room in a hospital, we wouldn't necessarily call it a clean room, but it is certainly a clean, controlled environment. And we're dealing also with air and surfaces, because microorganisms in the air will settle out on surfaces. Okay, so we need a different guidance and approach when it comes to the different industries because of different challenges. We also need to deal with the fact that trying to measure microbiological microorganisms is quite difficult, and the current science of environmental monitoring uses lag indicators, where in fact we sample, then we incubate for a period of time, and then we enumerate in terms of colony forming units. But it's a blunt instrument, whereas in particle counting, it's real time. In microbiological monitoring and measurement, it takes time, a week, if not more. But there are other techniques in trying to improve the speed of monitoring. And we've also got instantaneous microbiological detection technologies, which will assist. But we haven't felt at the European level that they're sufficiently developed to replace traditional CFU-based methods. That's the current status in the European EN 17141.
Maybe I can ask one of my questions here, Connor, especially
Yes.
this rapid microbiological methods. When we take a look at it, there are a lot of new technologies increasing, especially luminescence technologies. So these technologies, when we take a look at it, what is the major issue that needs to be addressed? The major issue that needs to be addressed on these technologies to become mature and replace the CFU-based traditional methods?
Yeah, the real challenge here is that we've got the issue of viable microorganisms which can sustain life. And then the real element of that is it's culturable, that we can actually recover it, because they are traditional methods. We lay out an agar or some level of a nutrient, and we try and attract the microorganisms to grow on that. And then through incubation, then we can see them appearing as colony forming units. The modern methods speed that up, but in the AMM, the alternative microbiological methods, or instantaneous microbiological detection, gives a real-time measurement. And the issue is to try and make those reliable. So the future will be trying to get more towards real-time measurements. And until then, we will still have to deal with the challenges of being able to culture and recover microorganisms that are difficult to observe and measure. So there's the challenges, and that's why it's such a big territory and a big area. And the European group, we've been trying to narrow down our focus and focus on traditional methods first, using alternative methods to go forward in the future, but really looking at the different applications. I hope that has gone away some way towards it, but the field of microbiology is vast and very challenging.
I see. Thank you.
So this goes back to this, and also microorganisms are very, very small, from below microns, submicrons in viruses to slightly larger, but they also go and they appear on skin flakes, for instance. So they can be much larger than 5 microns, which would be the traditional measurement, maximum measurement on real-time particle counting, and you can have them up to 100 microns. So there's a significant challenge around the size of how the microorganisms appear in particles, and that between organic and inorganic, right? So we need better clarity around that, and that's some of the challenges we have to deal with here, right? So let me try and give you a summary of the evolution, and it's an evolution, it's not a revolution, and how we've actually taken the revision of the European ISO 14698 into the new version of EN 17141 in 2020. So when we looked at 14698, we saw that it was not in line with the current ISO 14644 approach of microbiological cleanliness. We were trying to bring out the fundamental requirement to establish control, and then you demonstrate control. There was a lack of clarity around classification versus monitoring. We wanted to use things like a checklist of things to consider so that the ISO standard sits above and can be real in terms of its applications. And of course, as I've just mentioned, the challenges between real-time measurement versus traditional indirect measurements, which again is sampling, recovery, incubation, then enumeration, and then the vastly different requirements and needs of the different industries, right? And then it wasn't up to date with the technologies in RMM and AMM, right? And we wanted to try and give an independent view of that. So when we come into the one of our challenges, the first one was that the regulated life science industries, right, of sterile medicines has long been established, and there is a lot of guidance already there, and therefore we need to be very careful that we weren't adding any new unnecessary guidance, and we did not want to be in conflict with the latest regulations, particularly into around Annex 1 in the PICs, right? We also had to address as I said, the real-time issues and measurements around AMM and IMD. But we still, and then try and deal with some of the limitations in the current technology of indirect measurements. So we had to determine what was the scope of the standard, and dealing with normative versus informative, the informative being application side with industries, what that division was. And we wanted to make sure that because there was still large parts of the ISO 14698 that was relevant, we wanted to keep what was made sense, right? Again, we had enough guidance already in life sciences, and there was an absence of guidance of medical devices, and that was a bit of a conundrum that we needed to deal with, and also deal with some of our combinational devices. And then, of course, hospital operating theaters are not clean rooms, but they're certainly clean, controlled environments. Okay, so we set up the European Working Group, and our program was originally on a 3-year program, which extended by a year. We wanted to carry on the work that was done in the original TC209 Working Group 2. And the key area was the original working group had a requirement to look for tables of classification. And we said, no, that does not make sense. We need to have tables that relate more to monitoring, but not classification. And we also needed to try and limit the scope because of the variety of microorganisms, from viruses to bacteria to fungi to molds and spores. So it was made up of subject matter experts from across the spectrum, from life sciences.
A very short question here,
Yes.
Connor,
Sorry.
because I'm getting this question several times from different sources. As we all know, all ISO standards has a systematic overview, and you said that there was one for working group 2 in TC209 between 2009 and 2014. What happened? Why we didn't see the new updated version of 14698 since the beginning of this first publish?
Okay, so this slide here shows that in the original working group 2, the request of the TC was to see whether it was possible to have tables of classification similar for non-viable or total particles in ISO 14644-1. And it became very, very clear because of the traditional methods of sampling and incubation and then enumeration that classification tables were not possible. And also we know that for instance, in Annex 1 in life sciences, the tables for microorganisms are purely for monitoring. So therefore, this issue of the difference between classification and monitoring became very important. So that was the reason we changed, and that working group 2 was unable to get to that consensus. And we took it on as a European working group item where we clearly focused purely on monitoring, and classification was deemed as not appropriate until sometime in the future we can get to a stage of real-time measurements. So I hope that answers the question. It was unfortunate. We spent
Exactly.
6 years and clashed over classification, and really classification was not relevant and not important, but that was the resolution that we were working off originally. So the European group was represented from across the board in experts from different countries. And we wanted to move forward and look at microbiological monitoring as the primary focus in our revision, which is what we've done. And again, it's worthwhile bringing us back to first principles, which is we really enshrined within the work of TC 209, is that the pillars of a contamination control plan or a contamination control strategy, as is now the term used in Annex 1 revision, it's not out yet, but that's the current thread on it, is its combination of engineering controls, which is the clean room, the facility, the HVAC, the rooms, the division, the onions control of different grades and classifications as you go through from outside, through gowning rooms, airlocks to the core, is made up of, that's the engineering controls, but then we need the people and how we behave and control and gowning and the SOPs and the quality management system. And the third one, which is sometimes not recognized as being really important, is the ongoing cleaning and disinfection that's necessary. The three of those are the pillars of a contamination strategy, getting to a contamination control plan. So going back to the evolution and revolution again, we wanted to bring all those into it. So we wanted to bring in this concept of establishing control. We wanted to address monitoring, not classification. And we wanted to focus on the industry and make the ability to use the standard more practical, and we extended the bibliography. Okay. We also created one standard, which we felt was important versus a set, two parts in the original one and one in other environments and applications. And we had to deal with contentious issues of endotoxins, viruses, and prions, which we decided to eliminate and remove from the scope to simplify the standard.
So
Again,
why
we had
there
to deal with
is
the measurement technology, which is, sorry,
why there is
Hasim, go ahead.
one standard is ISO 14698, but two parts in the old version? Why there is two different parts instead of one single standard?
So as I show you in some slides to come, the original 14698 parts 1 and parts 2 was broken down into methods, and then part 2 was the evaluation of the data. And we felt it was important to bring it into one contiguous single standard to make it simpler to use and apply it. So the structure of the standard changed to reflect what we were trying to do, which was to establish control and then demonstrate control, but the methods of measurement are common in both. And we'll see it forward in some slides to come that may become more obvious. So as I said, we wanted to deal with the measurement technology and the advances and where it fitted in our view today from an independent perspective. So quick summary, we wanted to maintain as much of the current standard that was practical and necessary and useful, bring in risk and impact assessment and control from the current QRM approach from life sciences. We wanted to clearly demonstrate between establishing control and demonstrating control, because that meant we could focus on monitoring, not classification. And we reviewed the scope because we felt the field of microorganisms and microbiological control was too broad. So we needed to look at it. We've removed endotoxins, viruses, and prions because they're difficult to measure, and inconsistent with the current methods. And then obviously the current one in ISO 14690 also dealt with textile and water, and we felt that water was not appropriate. So we carried on from this and we looked at the independent view. We focused very much on culturable versus viable and how we dealt with recovery and the ability to actually measure microorganisms, and that's a very difficult task with traditional methods. And we want we want to follow advances in science, right? We wanted to bring out the difference between clean rooms and clean controlled environments, and then really give direction to different industries from an informative perspective. Okay, so in terms of decisions, we made the following decisions. One is to keep the relevant parts. We were not going to give new guidance in life sciences because there's enough guidance there. We wanted to add guidance for medical devices because that was missing. Focus on both food and hospital operating theaters, that they're clean controlled environments but not clean rooms. And we needed to narrow the field of microbiology, so we removed endotoxins, viruses and prions. Okay, and again, remind us that established control is now picked up in normal section 4 with the measurements in 6, and in demonstrate control is picked up in EN 1741 on section 5 and 6 for measurement. So let's see how this appears, right? And a quick reminder on what established control means. You carry out your risk assessments, you identify your critical control points in the environment, you assess those against and if there are regulatory requirements, and then you set performance requirements in terms of not to exceed limits. Most of this you can see in the life science industry is in Annex 1. And then you do the usual certain alert and action levels as part of an environmental monitoring plan, and then you design your contamination control plan. And again, this will come up later on in terms of questions on alert and action levels and designing an EM program, which I'll talk about shortly. And demonstrate control, it's about monitoring, it's a plan, evaluating the data, which originally was in part 2 of 14698. We wanted to bring it back into one single standard. And we all know the trend is your friend because we're looking at trending, and that's why it's about monitoring and not classification. How effective our monitoring plan needs to be reviewed on an ongoing basis, and then update it so it's relevant, and we're continuing to have confidence that we're demonstrating we are still in control from a microbiological perspective. So here's a comparison between the EN ISO 14698 and the EN 17141. So here we have part 1 here and part 2, if you can see my mouse. But if you add in the number of pages, there's not a lot of difference in pages. The total number of pages is still around, here we have 52 versus 32 plus 11. The normal section is slightly, normal section is slightly less in 17141, but the overall standard quantity in pages is similar, right? We excluded considerations of endotoxins, prions, and viruses. And we focus very much on establishing control and then how to demonstrate control, right? So here is the contents, the front contents pages of the 2 standards. And you can see here, we're still focusing very much on risk assessment, but we're moving into establishing control and then demonstrating control and then allowing the microbiological measurement methods, right? A lot of which is covered in here, but you can see in the second part of the old EN ISO 14698, it was dealing with the evaluation of data, okay? And we brought all of this in to section 5 in EN 17141. Moving on to the informative annexes. A lot of these we removed or brought them back into EN 1741. Some items on textiles we removed from the standard because in Europe it's already covered in EN 14065. We also dealt there was enough detail in other standards on laundering processes, and we took out liquids. We removed it completely. And obviously training has moved on enormously, and we decided that we would bring that into the normative section, that you need to have a competent training program, but we didn't feel the need to have a significant amount of detail as an informative annex. Okay. And on the other side, we moved very much into taking a view on applications, and we picked 4 applications that were primary concern. The first one being life sciences on pharma and biopharma, but we also brought out medical devices as a separate informative annexes. And then we dealt with healthcare and hospitals in Annex C. And then the informative Annex D deals with food applications. And then we left the final two annexes to deal with traditional methods in Annex E and the challenges around, mainly around culturable versus viable. And then Annex F, we have a treatment, independent treatment, I would say, on rapid methods and alternative real-time methods. Okay, and that's particularly important in terms of new sciences. Okay, so what I've done so far is trying to take you on a journey of and join together some of the thinking of the original work in the TC209 and trying to bridge that with the EN 1741. So we have a competent standard, we believe, in EN 1741, but it is a different number because of the confusion with 14698. The intention over the next few years is to realign the ISO world and bring together EN 1741, that we will end up with a new ISO global standard for 14698, probably in 2022, but it will be based on EN 17141. Okay. So let's talk a bit about the application side of it and the relevance, right? And some of the nuances, right? So clearly there are the four areas here. The other category covers things like space, optics, and other areas, but we felt that the industry requirement really was for the first four. We extensively went out in 2016 and 17 and talked to industry and asked them what they wanted. And they really come back and said they really wanted separate informative guidance on different applications because they're so different. So let's try and go through some of these and see where the differences are. When you get into pharma and biopharma, then the driver is product quality and patient safety, but there already is enough regulations, right? Okay, so we were not interested in adding any new regulation. We wanted to encourage EMEA and Annex 1 to refer to the new EN 1741. And we wanted to refer to existing good guidance, which is already there through many documents. When you get into medical devices, we have the same product quality and patient safety requirement, right? But we're also into bioburden because some devices, mostly medical devices, can be thermally sterilized, but some cannot be. And they also come in various materials and sizes and shapes. And we've also got different types of classifications of medical devices between class 1, 2, and 3. And then, of course, the further combination is they can be combinational products, which adds another complication layer, right? We have a European directive in medical devices since 1993, and we've also got 14971 in risk assessment about acceptable risk, but there was no specific guidance because the EMA PICS guidance in Annex 1 is around sterile medicines, not medical devices. And the FDA guidance comes close to it in terms of sterile processing, which is only a small part of medical devices, as most medical devices are thermally sterilized. So there was an absence of good guidance from a microbiological control perspective in that. So,
wow. I have always assumed, Connor, EMA and FDA regulatory guidance are addressed medical devices as well. And you said this is not the case, right?
Correct. So if I go back and you look at it here, in this slide here, the FDA guidance from 2004 is in sterile aseptic manufacturing processing or sterile processing. And so that applies to medical devices that are sterile, but doesn't to ones that are not sterile. And then the EMA PICS and GMPs are about sterile medicines, not necessarily medical devices. So it would cover combinational products, but doesn't deal with thermally sterilized medical devices. And that's why we felt that there was not sufficient guidance on that area there. And you can see here is the contents of informative Annex B on medical devices. And we've given some examples. So you've example 1 deals with where you've got a sterile medical device because thermal sterilization is not possible because it changes the nature of the medical device. And then we've a separate example for one which is thermally sterilized, which is the commonly used approach at the moment. And then obviously you've some elements which are non-sterile, right? So again, we try to give good guidance and examples of how to establish control and then demonstrate control within those.
Okay, thank you.
Okay, and again, I'm going to talk in a moment a bit more about how this applies and gives the guidance. So here is an example where we've taken a leaf out of the book of Annex 1, which has a table for microbiological monitoring. And you'll notice here that the same columns are the same as in Annex 1, but the categories are down here. We've called them 1, 2, 3, and 4 rather than grade A, B, and C, and D, just to be careful to distinguish, okay? We're using the same type of wording in terms of appropriate alert and action levels, but it's all about monitoring. This is not a table for classification. It's designed around monitoring.
So we can assume that this category 1 to 4 is like in GMP Annex 1, grade A to D.
Similar, but we're not stating it directly, but effectively, yes, because the numbers for monitoring in each of these are identical to Annex 1 table. It's to be careful that we're giving guidance that hopefully will allow the PICS and EMA and other regulatory agencies to refer to EN 1741 in a way that's suitable to them. We've also added notes on endotoxins and pyrogens. While it's not in the scope of this standard, should be carefully considered in terms of medical devices. So it is important, but we're not dealing with this in the standard, okay? Again, we're talking about average values of culturable viable microorganisms, okay? And then again, we have the similar notes that are in A and B in Annex 1. We're making reference to aseptic processing of sterile medical devices and EN ISO 13408-7, okay? So we're making this table relevant to microbiological microorganisms. What's really interesting in this here is that this is for monitoring, and you need to start off and establish your baseline microbiological contamination levels in the address state and then operational state, and that allows you to set up your alert and action levels.
So
okay.
we have one question from our attendees. Thomas Löf is asking, still confusing to me if you must use both settle plates and active air sampling, or can you use one of them only?
I suppose the answer to that is that the table here is showing both requirements from a regulatory requirement, okay? And in practice, we've got to recognize that the airborne sampling talks about the challenge that's within the air. The settle plates are a measurement of the settlement and the particle deposition that comes out of the air. So in theory, you could argue that if I have microorganisms that stay in the air and I have a very effective contamination ventilation system, and the particles and the microorganisms are carried through the airstream and out of the clean room or clean control environment, then they're not acting as a risk to the product because they're removed. The settle plate gives the element of what is the deposition side of that. And as you would expect from particle physics, the larger the particle, the heavier the particle, then the more likely it is to fall out and deposit on surfaces and not necessarily be carried by the airstream. So if you have a very small microorganism like a virus that is on its own, or a very small aerosolized droplet, then it can be carried in the airstream. But larger droplets will then carry that virus, and that's the issue we have with COVID-19 at the moment. And the 2 meter rule is the danger is that the larger droplets containing the COVID-19 virus fall out from breath, speaking, singing, shouting, or otherwise, and it falls out and deposits on people or is breathed in by other people within that 2 meter radius. Okay, we believe that once it goes past 2 meters, the particles are much, much smaller, but it is still a risk. And that's where we talk about masks and face coverings and ventilation and all that bigger issue around COVID-19. Unfortunately, you follow the regulatory guidance, but in terms of other applications where we're not looking at regulations, then you do have the ability to look at the application. But this is really trying to show you that in life sciences, you have air sampling and you've got settle plates, and they are different. They tell a slightly different story, but they are important, and you need to do your risk assessment to see how it applies in your case. Okay, I don't know if that gives a complete answer to Thomas's question, but it does explain the context of the subject matter. Going back to the table here in medical devices, the microbiological environmental monitoring plan really focuses on saying, what are your objectionable species that you want to monitor, or is it the total CFU count? And then how should you evaluate the results in terms of trending with adverse and then corrective action? And that's why where we're looking at bioburden in most medical device clean rooms, you're looking at that as a maximum, because that is when you're going for terminal sterilization. That burden, once it's sterilized, is left as inactive or inactive particles that may affect the performance of the medical device. So we believe that this element adds good guidance from a medical device perspective. So that's why the actual annex has 9 pages, whereas the informative annex on A for life science only has 1 page. So we've put a particular level of attention because that's what industry wanted. When we get into hospitals, we've limited information on the Annex C because there's a lot of it around in other areas. Plus, it's extremely variable because it's really around infection control, and operating rooms are only one part of a healthcare environment. And while we're looking at infection control, we also need to look at cross-contamination, the issue of isolation because of immunocompromised patients, sterility. We've also got aseptic compounding units, radiopharmaceuticals. We've also got instrument sterilization and biosafety. So here's an example of some of the wide variety of applications in hospitals. So really it's the normative section, and the application of risk assessment and establishing and demonstration control is important. And there's a lot of industry guidance otherwise on that, but it's a very, very broad area. And there's almost so much you can do in a European standard. When we get on to food, food again is another area, and it's very much around pathogens in food. So not all microorganisms, just the ones that can cause illness or in some cases death. And we're also dealing with food quality, the visual impact and spoilage. And there's just an example in the middle there of the content of the informative annex. So we're really dealing with establishing control, demonstrating control, and then we gave an example in food manufacturing to give an example, right? So in food side of it, right, we're really looking at the spread of bacteria, yeasts, and molds that can grow in the conditions of food, right? And we want to try and keep the air in the immediate vicinity of the food being processed free from microbiological contamination. And this, as you can imagine, can reduce the need for pasteurization or flash freezing in certain processes, or the unnecessary addition of artificial preservatives. And though food is on an outlier in kind of clean control environments, where it's been finally processed from a manufacturing viewpoint is a very important area to keep it free of pathogens, to try and extend the lifetime as much as possible and not add in unnecessary additions and preservatives. So very much in the food manufacturing area, it's around clean zones and clean work surfaces. But a feature of food is very large surface areas for the preparation area, which is quite different to life sciences. And it poses different challenges. So the desired outcome of obviously a healthier food product is the lower foreign content as preservatives, no pathogens, having a longer shelf life, and an improved visual presentation. So that's why the food manufacturing was different. So in the normal section 4, which now pulls everything back together, because I want to go through now some of the requests in terms of looking at about monitoring and a monitoring plan. So I'm going to change tack and go back into the normal section here. And you'll notice here we talk about the risk assessment. Here we talk about establishing control, and then looking and having a microbiological environmental monitoring plan, looking at locations and frequencies and alert and action limits. So they're all covered in the normal section 4. Okay, and then in section 5 deals with demonstration. So it talks about verification of your control system that is working, what to do in terms of out of specification investigations and CAPA, what to do about records, what about sample tracking, the integrity of results and data recording and evaluation and trend analysis, all of those coming together. So let's talk, and sorry, forgive me, and then we measure methods on the traditional basis in section 6. And that really we put additional information on the choice of the sampling method, again dealing with volumetric air samplers and dealing with the issue of culturability versus viability and some of the areas around that, including incubators as guidance, but based on traditional methods. Okay, and then just finishing off, there's some of the issues on Annex E as an informative annex that gives guidance on all of the issues between swabs and sponges, the media suitability, the challenge of dehydration of the media, the incubation, collection efficiencies. We talk about the D50 number to give some level of comparison between different airborne samplers. And it's a big territory around the traditional methods. So Section 6 talks of measure methods, and then informative Annex E talks about the informative information and guidance around that. And then finally on Annex F, just to finish off on the standard, we're dealing with RMM and AMM and some of the issues around that, particularly things like verification tests to see on reliability, alert and action levels, and how to deal with that. So in answering to some of the queries that came in and when I was asked by Hasim, he asked me specifically to look at a number of items in terms of environmental monitoring plans and the guidance that comes in the UEN 1741. So really this is the standard way of doing it. A lot of this is covered in other documents like TR13 from PDA, but it just is setting out the requirements to have a written environmental monitoring plan based on a risk assessment, and then deal with the types of EM that goes with that, the locations, the frequencies, setting alert and action limits. You're looking at levels, but then you have a limit, and then looking at where the role fits in of traditional versus RMM and AMM, right? And we're saying basically RMM and AMM have real application in process monitoring, but not necessarily on compendial release. The EM sampling incubation protocols, the data analysis, and then CAPA and investigation procedures in OOSs. Okay, so basically your plan must cover all of those. Okay, so looking at locations for environmental monitoring, again, this is standard stuff straight out of industry guidance. You're applying a risk assessment. You need to look at the process and the workflows, the people and materials, the interactions, the traffic routes, where are the interventions and manipulations, and these are all different for the different applications. Where are the difficult areas to access and clean? Look at those locations for monitoring, and then look at ones that you have a history of issue in the past over. And we're recommending that HACCP is a very good tool. So you need to understand your process, and you look at your hazard analysis, your critical control points, your alert, how to monitor at each critical control point, and then what do you do in the event that you've got an OOS and you need to do corrective action and preventative action. Frequency of environmental monitoring. In the sterile areas, you need to assess the operations during filling at the critical areas. Support areas, you're looking at the frequency based on a risk assessment. And then you're looking at things like obviously following maintenance work or before and after shutdowns. They would be good areas to look at from a risk assessment viewpoint. In the general area, you're looking at the workflow. What is the activity? How long is the activity? What type of equipment and process use? How many people are involved? What are their interventions and manipulations? Right? And then a lot of it is down, how long is the exposure? Right? Again, there may be environmental impacts of temperature, humidity. It's not possible at this level to give any more guidance specifically, but these are the things you need to be looking at, the things to consider, the checklist that you should be looking at, and that's what's discussed in the standard. Then, of course, the question is, when do you carry out the environmental? What time during the day? So obviously you must be in operation. And then you need to look at your shift patterns and critical processes and you focus on worst case time of events. And again, we're back to the risk assessment. We're back into critical control points, critical workflow. What are the processes? When do people come in? How do you move materials? How do you set up lines? What are your loading operations? What are your critical operations? And on all, it's about manual people interventions and manipulations, because that's where the highest risk is. Okay. So when and how, or sorry, what's the duration you're monitoring? Well, you need to, in the aseptic process, it needs to be for the full duration of the operation. And you need to be looking at things like active air sampling near the start, the middle, near the end, and then surface environmental monitoring at critical locations, settle plates, right? Again, a key focus is on people, and it depends on the risk in operation. So finger dabs, you know, around the sterile, the aseptic connections, any compromises, and then before exiting grade B would be typical in terms of the aseptic area, and it needs to be risk assessment in the other areas of grade C and D, for instance. Okay, active air sampling and the timing to do that, remembering we need to do 1 meter cubed at each point. And then surface environmental monitoring, depending on the nature of the operation in the support areas, right? And exposing settle plates for 4 hours where possible, because that gives a long duration of the operational activity. And again, on people, it's depending on the risk assessment. So choice of people, the training, the constant vigilance, all of that is very, very important. So when we're looking at alert and action limits and levels, right, then clearly we're looking at understanding your baseline. And after that, you're looking at best guidance that's around. Again, I'm just giving one example, both PDHER 13 and PHSS and different organizations have very good guidance in terms of setting alert and action levels and limits, right? And particularly, you need to build up your data and your baseline information. And that typically takes probably 6 months, or when you have a statistically sufficient number of samples. And that allows you to set your levels and then ultimately have a limit to what you want to limit work to. And ideally, some form of process-related statistical method or model should be used with the scientific rationale. The most important thing is you understand your process and understand how you're doing it, have it documented, follow the plan, evaluate the data, and then modify it as required. Okay, so let's look specifically at Annex 1, because there's a few interesting things here on it, right? So I'm going to look at the standard control. We already know, we want to establish control. And I want to really move into this one here and talk really about classification versus monitoring. So this table here is a combined table which comes from Annex 1, but it doesn't exist on its own as a single table. It's 2 tables, right? And the first table deals with at rest and operation for particles. And the second one deals with microorganisms, but this is for monitoring. The particles, total particles for monitoring deals with classification, because Annex 1 refers to 14644-1 classification, real time. But when you get to microorganisms, it's monitoring, baseline information. But because we sometimes combine the 2 tables, we get confused between the 2. Hasim, shoot.
Yeah, Connor, so does this mean there is no classification table for microbiological contamination control?
Correct. As shown in the slide here, the only table for classification is in here, which is ISO 14644 for classification. Annex 1 deals with microbiological control and microorganisms, and it's monitoring. It is not classification. And this hopefully puts it together with this slide here, showing that on the left-hand side, total particles, airborne 14644-1 is about classification. The -2 is about monitoring of airborne particles, right? But when you get to microorganisms, we've got to deal with the fact that they vary in huge levels of sizes, up to skin flakes, 25, 50 microns and beyond. We've got nanoparticles down here in viruses. And the contamination control strategy in Annex 1 is a contamination control strategy is a really important point, right? And in this continuum, the microorganisms in EN 1741 fits in here, both airborne and surfaces, but it excludes viruses. And some of these microorganisms have an organic chemical nature, some of them can be larger sizes, so it's quite a complicated area. But I just really want to hear in Annex 1, there's a difference between classification and monitoring. You classify total particles.
And I think that's the most important point here. Sorry to interrupt, Connor, but TC209, we have the same discussion for a long time. For classification, there is only one method available, which is particle counting, according to ISO 14644-1 2015 version. And the rest of the limits are all for monitoring, including microbiological counts.
Yes, that is correct.
Okay.
I think that's very, very important. And I'm trying to go back a slide here just to show you that all of the other standards in ISO 14644 out to here, whether it's microorganisms, chemical, nano, are all monitoring. And that's a very, very important point. We get confused sometimes, and I go back to this slide here, when we see this combined table in industry between particles and microorganisms, that we sometimes think this is a table of classification. It's not. It's only a table of classification for airborne particles, or what's sometimes called non-viables. And on the microbiological side, we're really talking about an operation. And notice it's in operation. It doesn't talk about at rest. It's microorganisms in operation, and it's monitoring. So quite an important area and confusion. Okay. And the important thing here in Annex 1 is that you have a contamination control strategy. And that needs to cover the engineering controls, plus the people, plus the ongoing cleaning and disinfection. All of those come together. So I noticed I've run over slightly more time, but to bring some closing remarks to bring all of this together. As I said, I was bringing you on a journey. And microbiological contamination control is a very, very broad and wide area, coming from the fact that we've an unseen enemy and we generate most of it and we bring it in even though we're gowned. We're still working with the current science of monitoring in the environment based on lag indicators of CFUs. We have real-time measurement is making progress for in-process monitoring and it will not replace EN 1741 in the short term. We're designing our engineering controls better using isolators and robotics, but unfortunately we cannot remove all people. What's interesting is that we need to deal with particles above 5 microns, and they're becoming increasingly important. And there's a new standard on 14644-17 going through final stages at the moment on particle deposition rates and their application. And above all, we need better guidance, right? So in summary, we're saying that below 5 microns, the engineering controls are very important, and measurements are a good indicator of that, particularly non-viable measurements. But once you go above 5 microns, right, we're dealing with operations, and environmental monitoring becomes very important. And viable EM is a very good mechanism of feedback of how well we're doing and how well we're behaving inside a clean room and clean control environment around the people and the SOPs. And what's really interesting is that when you go above 5 microns up to 50 microns and micro carrying particles, right, the measurement using cleaning and disinfection and our EM around that is a very good measurement how well we're doing in our cleaning and disinfection. So it's quite important that the EM is a really important part of microbiological contamination control. Okay, so forgive me for going past our 50-minute general guideline, Hasim, but I wanted to really bring you through the journey and the role and importance of EN 1741. And hopefully in the ISO community at TC209, we're going to bring that on board and move it forward. But certainly in Europe, we will be applying EN 17141 over the next few years. We've very positive feedback at the moment, and we look forward to seeing the feedback and the application. Thank you.
Mm-hmm. Thank you very much, Connor. We have a couple of questions, which I will start with one of them. Why in the monitoring table in the grade A, the limit sets less than 1? Why not write as a 0? And why does it exactly mean to be less than 1? That's our first question.
So I suppose a very simple answer is because we took a leaf out of the current Annex 1, we decided to keep the same numbers as they were and not get into a detailed argument beyond that. And I suppose it also relates to the subject matter of false positives and the issue around the typical conundrum, what sterility means, and the definitions that go around that. So rather than get into that technical argument, we decided to leave the content as the original content in Annex 1. Again, we had a lot of discussions among the microbiologists in the European Working Group, and it is a very tricky subject, as I'm sure the person who asked the question knows that themselves. So it is, the jury is still out. So we decided not to add any more conflict. We just decided to stick to the same item that was in it and use the term less than 1.
Okay. Considering EN 17141, one of our questions about ATMP. Is there any new guideline for ATMP method?
Okay, so this again is a very tricky one. This is the advanced therapeutic medicine products, or gene therapy products as we call GCTs in the US. And we have a real challenge here because the compendial methods can take 2 weeks for release, but an ATMP can have a short shelf life going back into a patient within hours. So really the focus, and you'll notice the guidelines on the regulations talk about the importance of in-process monitoring. And the application of EN 1741 allows us to focus really on establishing control and then demonstrating control. So yes, you use your RMM and your AMMs as ancillary information, but you have to take decisions before you can do a compendial analysis in a traditional method. And that is a real challenge. And our recommendation is you focus on the process, you focus on the data. Okay, but unfortunately, when you have personal patients, the amount of material you have to test is limited, and the shelf life is limited. So these are real challenges. So because this standard we expect to be out for a number of years, we decided we were not trying to answer all of the questions. We tried to give the best guidance to apply the standard around establish control and demonstrate control, and use that data along with additional measurements on real time and measurements on EIMD as to give the best guidance and data to say we believe the ATMP is safe. But you won't know for sure until you finish your traditional methods, and that will be long after the patient has been treated. But the risk is the patient may die in the meantime. So that's a real challenge.
Yep. There's another good question. Why is there a quantitative count whereas trends give more information? Why we are going through the quantitative counts instead of trends?
Well, my answer to that would be that the trend is your friend is a really important one. Okay, and the quantitative count is there because it is already in the tables in life sciences. So we haven't changed that. The guidance is already there, and we've taken the similar guidance in medical devices. And that's why, as we all know, that if you have a limit of 200 for argument's sake, and you get a count of, for argument's sake, 10, 20, 10, 20, 40, 50, 40, 50, 30, and then 120, then you're required to do a kappa and an OS, and you're nowhere near your 200 because of the uncertainty on the traditional methods. So we're just following the same count that's there as a limit, but we recognize we need to do the baseline characteristic and understand the baseline level and then look at the trending. So really the trending is the important one, but it goes back to establish control, demonstrate control, watch the trend. And if the trend is going the wrong way, then you intercede. But we're not setting new quantitative numbers. We're taking the numbers that are already there because it is such a difficult one. And it's really around the uncertainty of the measurement and the difference between culturable and viable.
Another question is, what is the
I'm not sure it answers the question, but I agree with trends.
Yeah, I
Sorry,
think so.
Hasim, go ahead.
What is the effective biocontamination control practices that suggested from your side as an expert? That's the question.
Sorry, Hasim, you broke up on that. Give me that question again, please.
Okay. What is the effective biocontamination control practices that suggested from your side?
Again, it may be my network connection. I'm sorry, Hasim. Maybe try again to see if it's any better.
Okay, sure. What is the effective biocontamination control practice? Because we have a different biocontamination control practices available. So what is the most effective one according to your knowledge? Which one you suggest more? I think that's the question.
So I pulled up the question here. What is the effective biocontamination control practices that's suggested from your side? Well, what we're identifying that is fundamentally coming from risk assessment, and it's looking for a review of the process particular to your application, and it's identifying in the normative section 4 how you go about that process, right? And that's the best practice. It's laid out in normative section 4, and then in normative section 5 on the how to demonstrate control. And I don't think we're talking about any new biocontamination control or microbiological control practices. Talking about normative standard and applying, then you follow what's in the normative section of how you do you carry out your risk assessment, you record it, you have a written and documented environmental monitoring control plan. You then evaluate it, and it gives all the various requirements in terms of the data, how you collect the data, how you use the data, how you evaluate what you do in an OS and a kappa. But it's not, I believe we're not talking about anything new. We're talking about just making sure that it's documented, you have a scientific rationale, and it's appropriate for your application. So in the life science industry, it's heavily regulated already, and it's already documented there. It's less so in other areas, particularly in healthcare and food. And we're just trying to give the relevance of the guidance to allow you to follow it. So again, all I can say is where the effective biocontamination control practices really vary depending on your industry and application, but it's asking you to follow a formal process.
I see. We have a couple of questions more, but I will take one more and we will be ending our session for today. So the question is about the settle plate and active air sampling locations. The question says, should we select the same location to be sampled both for active air and settle plates?
Okay, so that's a very interesting one for two reasons. The first reason is that if you have a high particle count from a real-time particle counter in an area where you normally don't, then that could indicate that you have a higher level of microorganisms within that count. May not, because it may be simply mechanical metal abrasion, but it could also be that you have a higher count of microorganisms. So it does have advantages that you are mirroring your non-viable measurements with your viable measurements and trying to give an additional picture and understanding of what's going on in the space. So if it's mirrored by a higher level of viable counts, then it is a good indicator that gives you a mechanism for an OS or a kappa. On the other hand, it's also important to recognize that in the latest 14644-1 and -2, they're separate, and -2 is for monitoring. And when we're talking about microbiological environmental monitoring, when we're looking at non-viables, we should be applying 14644-2, which talks about a risk assessment. It talks about worst case locations. And while you should start off with the representative locations that comes from -1, you don't necessarily need to do all of the same numbers again. So one needs to be careful that you're not adding in unnecessarily a number of locations simply because it comes from 14644-1. So yes, it is useful when you get high counts in non-viables to give a picture or a direction for your viable EM, but you don't necessarily have to use all of the same locations. It should be done on risk and worst case locations. Okay, so -2 for airborne particle monitoring is a very important standard and should be looked at very carefully. And EN 1741 is written around recognizing that of the combination of an integrated EM program that deals with non-viables and viables. They both tell you an overall story of how well you are confident that you're demonstrating you are in control from a microbiological perspective.
Thank you very much, Connor. We exceed our time, but for a good reason. We answered more questions than we planned. There are a couple of questions we received. Of course, we will get back to you with an email. I'd like to thank you, Connor, again for joining us today. And please.
Thank you, Hasim. And yes, I am very happy to look at the separate questions and then write a reply directly for them. And maybe give guidance to where it appears in the EN 1741, and hopefully that will add value to the attendees. And Hasim, thank you for inviting me. It's a really important standard, and we are trying to promote it. It's appearing all of the experts in the working group are going out to promote the standard and explain the journey we are on. So it is very worthwhile. So please buy it, use it, and give us feedback. Thank you.
Thank you so much, Connor. Great to have you here today. Have a great day, everyone. See you next month on our webinar. You can check our website to see upcoming webinars, also our LinkedIn corporate page. So let's stay in touch. Have a great day. Thank you.
Thank you.